Consider this problem. A frame B was rotated about the x-axis 90 degree. Then it was translated about the current A-axis 3 inches before being rotated about the Z-axis 90 degree. Finally, it was translated about current O-axis 5 inches. So we can see that we have two kinds of transformations. One is rotation and translation happening here. So when we look into the first motion, we can see that the frame B was rotated about the x-axis. Rotation is happening along the x-axis by 90 degree, that is with respect to the reference frame. And the second motion, the translation is happening with respect to the frame or NOA frame, okay, by towards the NA axis. And the third motion, again rotation is happening along the Z axis, that is along the with respect to the reference frame. And then we have translation happening along the O axis by 5 inches, that is with respect to the NOA frame. So we have a combination of translation and rotation, and that too with reference to reference frame and with reference to the NOA frame. So first part of the question is like write an equation describing the motion. So how many motions are described here? 4 motions are there. First we have to write the equation for that. So first rotation is happening, okay, along the x-axis. So we pre-multiply it, that is we have written here r x comma 90. Okay, rotation is happening along the x-axis by 90 degree, that is r x of 90. We'll write a rotation matrix for this. And then the second motion is happening is the translation about the A-axis, that is about the subframe, right? So how we can represent T 003, that means the translation is only along the A axis. This is the NOA frame, and the last one represents the A, translation along the A axis. So it is 3. Okay, so since it is with respect to the NOA frame, we post multiply it, that is after the rotation matrix we multiply translation matrix. And before being rotated about the Z axis by 90 degree. So again we have a rotation happening in the Z axis. Z axis means what? It is with respect to the reference frame. So we have to pre-multiply it. That is why we have multiplied this rotation matrix along the Z axis in the front. Okay, see this. Then the last motion is it was translated about O axis by 5 inches. So since it is with respect to the NOA frame, it has to be post multiplied. That is why this translation is given at the end, T of 0, 5, 0. So this is the O axis, right? This is the N axis, this is the O axis, and this is the component in towards the A axis. So since translation is happening in the O axis, we have given 5 over here. So you know how to write the matrix for rotation or transformation matrix for rotation, okay, along the Z axis, along the X axis, and you know how to write the translation matrices also. So we have written it. So this describes, when we multiply these 4, we will get a 4 by 4 matrix, and that describes the motions. And the second part of the question is find the location of the point P with initial position 154 attached to the frame relative to the reference frame. So what we have to do, we have to find the new position of this NOA frame, the position of the point P. Now some translations and rotations have happened. Now what is the current position of this point P? Okay, so this can be found out by multiplying this. You have some equation. We have written the equation for motion, and we have got a 4 by 4 matrix. When we multiply these 4 matrices, we have got an answer, right? So that answer multiplied by, we can represent this as a vector, right? 1, 5, 4, and the scaling factor 1, right? We multiply the resultant of this A part into this, okay? We'll get a matrix like this with values 7, 1, 10 and 1. Okay, so this is the solution for this. So kindly work out by yourself. Okay.